Welcome, everybody. Good morning, good afternoon, and good evening. Thank you for joining us today for the Intelligent Process Manufacturing discussion that we'll be having with our guest panelists from Microsoft as well as Uptake about demystifying a digital twin for agile process manufacturing. Many of our customers have shared their challenges and are tired of platforms that have been promising a digital twin that works wonders. And the problem is that they don't all understand all the variables that you face in manufacturing, and they need an approach that internet connects different systems together with different external components. And as a result, we've put together this wonderful panel today that we'll be discussing a number of different topics from a perspective of taking multi-vendor components and bringing it all together. We'll be discussing platform versus ecosystem, approach to digital twins, the role and of importance of cataloging your data to overcome sustainability challenges within digital twins, the importance of flexibility in designing a solution, and building a digital twin using multiple components than what other manufacturing companies are using and how they're using their digital twins. And of course, we'll be talking about advanced operations to improve workforce, transition to clean, and reimagine energy. Wonderful. So now I'd like to introduce our guest speaker. So just so you know myself, my name is Leanna Chan, and I am the head of global business development for Uptake. And I'd like to introduce our guest speakers from Microsoft. Manish Amin has over 25 years of experience in helping companies obtain value from analysis and operational data. He's an IoT advisor of digital transformation within Microsoft. His expertise include IoT, predictive and prescriptive analytics, data management, data governance, and defining and implementing industrial digital transformation programs, as well as designing and developing numerous industrial software products for a variety of different solutions and verticals. His expertise include addressing complex data analysis and the integration from multiple sources, permitting centralized monitoring and management of distributed systems and different structures onto one platform. Next, I'd like to introduce Mohammed Masroor Ahmed, and he is an IoT advisor of digital transformation from Microsoft as well. And Mohammed brings over 25 years of experience from the IT world. He has been with IBM for over 23 years and has built enterprise solutions leveraging artificial intelligence and IoT. His enterprise systems management solutions have been in progress with different Fortune 500 companies globally. He has been with Microsoft for over 3 years and helping customers with digital transformation by building IoT-based solutions. He identifies and designs complex business problems and transforms them using emerging technology, building value and competitive advantage. Next, I'd like to introduce Dr. Dave Shook. He's the Chief Digital Officer at Uptake and has over 30 years of experience in helping companies obtain value from analysis and operational data. His expertise include defining and implementing industrial digital transformation programs, as well as designing and developing numerous industrial software products and solutions. His specialty includes addressing complex data and integration from multiple different sources, centralized monitoring and management of distributed fleets of assets in large groups of different operators. He has several years of experience, including upstream oil and gas, production, gas transmission, refining, petrochemicals, plastics, forest products, minerals processing, water, wastewater treatment, as well as renewable energy. And last but not least, I'd like to introduce Alvaro Rosso, who is the head of application delivery at Uptake and brings over 25 years of experience of integrating and applying digital and operational technologies. He has participated in customer advisory boards, providing subject matter advisory on real-time series data analysis like historians, as well as manufacturing execution systems, MES. And he has been instrumental in the development of digital offerings with mining and oil and gas, including digital transformation frameworks of digital twins and operating assets in remote services that have provided enablement as part of COVID-19 contingency planning. He has been a big contributor to the Global Mining Guidelines Group as part of the Interoperability Working Group, as well as the Digital Twin Consortium as co-chair of Natural Resources and Mining Group for several years. We're looking forward to a great discussion today. Please feel free to put any questions you have in the chat, and thank you for everybody for putting yourself on mute.
Thank you, Liana. So what is a digital twin? This is just a reference. This is the definition that was defined by the Digital Twin Consortium. Both Microsoft and Uptake are part of. And I see as well Gavin on the line. So he's also a partner who is part of this Digital Twin Consortium, putting on the spot as we go. But if you're interested to get involved in the Digital Twin Consortium and or other working groups, please send me a note, alvaro.rosso at update.com, and I will be happy to connect you with the working group leads. So why do we require a definition for the digital twin? And I would like to highlight the last sentence as a fundamental part of our discussion today. Digital twins are motivated by outcomes, tailored to use case, powered by integration, and built on data, guided by domain knowledge, and implemented in IT and OT systems. So the process manufacturing has been showing precisely that behavior. Digital twin use cases have started to be applied across the entire value chain, and it has started to build upon the IT and OT applications and technologies that they are being tailored to the relevant use cases. Particularly the digital twin offerings that we have seen mostly in the manufacturing sector has started with the product technology and development side of things, where there is a lot of emphasis around the product redesign and the custom virtual prototyping, but that quickly evolved into other areas where people start to apply into the procurement areas, where they have virtual environments that they can facilitate for third-party suppliers to go and do the safety visits and surveys to collect information, and that helps accelerate the procurement process in many occasions, and at the same time, improve some of the safety ratings as well, as you minimize the amount of people as well on the field. And that started to evolve into other areas, such as the human resource management component, where you are taking also the environment to basically facilitate not only the training of your people, but at the same time exposing that into college students and university to get them familiarized with the environment, driving a little bit more cross-discipline collaboration across the board. But once you go into the true manufacturing sector, where you have the inbound, outbound logistics through the operations, the emphasis has been around planning and optimization across different areas. Certainly, you're moving materials from raw materials from one side to the next. Obviously, there are different components around the manufacturing sector that you have to take into consideration. Some of the process manufacturing will be more batch oriented, some other ones will be more continuous oriented. But nonetheless, there are the process manufacturing that we're talking about. There are chemical reactions, changes that happens through the raw materials to produce an end product that basically gets offered into the market. So things like process optimization will be, typical applications that you start to apply along the lines of predictive maintenance or quality management into this component. Once you go into the warehouse, then it's more focused around the inventory management aspects and the fleet management component. But the fundamental things that is driving quite a bit of change is that through this process of the digital twin, we are seeing, a change from the marketing and sales, where product-centric to service-centric type of business models started to materialize, where people are, providing more in terms of air-consuming type of offering, guaranteeing the air consumption for the compressors, as an example, is a big change as well in the market, and certainly something that we'll need to consider as we go. So once it goes into these services, a component is now looking at in terms of how we actually serve your customer in a different manner by providing a view into how the products and the operations actually work, and that basically helps drive some of the third-party integration to improve the work order management system aspects. And I think Microsoft has some examples that can provide through the presentation as well, but I will leave it there. Why am I providing these examples? Number one, we have to come to a realization that many digital twins will need to be coexisting into the manufacturing value chain. There is no single platform that fits all, and the ecosystem of solutions needs to be the way to go. This is why we are here today with Microsoft to talk to you about the digital twins. Second reason is we need to define a digital twin strategy that will allow us to integrate them all. That means that open APIs, data cataloging are two key components that will enable these digital twins to exchange information in the future. And since there is a lot of reliance on assets and equipment through the entire process, asset management and predictive maintenance is a common use case across all of these areas. So the focus of our discussion today and an area of strength for uptake. So our goal is very simple. We provide to our customers with a scalable, secure ability to connect their machines, people, and data together to accelerate and unlock AI-enabled industrial intelligence to optimize costs, manage risk, and increase revenue. For us, the scalability and security are provided by the Azure Cloud technology. Our solutions utilize the cloud-native components. We tie that with our expertise to connect to the machines, to extract and move the data to a central repository in Azure, where we can prepare and enrich the data for data science applications. One of those applications is our asset management, asset performance management solution that enable organizations to understand their current maintenance expenditure, identify the risk, and define better strategies to increase its revenue. And with that, I'll leave it with Dave.
Okay. Thanks, Alvaro. So let's talk a bit about how companies use digital twins. So within really any environment, but manufacturing in particular, what's going on is there's a manufacturing process going on. There's a value-adding process that is happening through a sequence of operations carried out by equipment. We collect information from that equipment. We think of this as the IoT data or streaming data or history, what have you. And there tends to be several different types of data that come in from the equipment. Some of it pertains to the equipment directly. Some of it pertains to the value-adding process. And so some of this data is things like data flowing directly from the control system, coming through a historian or directly from the control system. Some of it, and that's this time series data down here. Some of it is engineering design data. So both design of the products and design of the equipment. Some of it is transactional data, and in manufacturing, the transactions that we're primarily interested in are two types. One is maintenance transaction type events on the equipment, and the other is supply chain and product movement transactions. So this is the receipt of goods, the shipment of goods, and depending on whether you're discrete manufacturing or process manufacturing, the movement of material from one place in the process to the next may be transactional or maybe time series. And then there's in the modern world with the advent of the industrial Internet of Things, there are sensors that can communicate directly on their own, or there are industry standard buses that we can connect IoT devices to and send equipment monitoring data straight to the cloud. Now, this data that's sort of flowing continuously is combined with structural information about the physical assets, about the manufacturing process, about product specifications. And so the continuously flowing data and history are placed into context by the structural information, so that the digital twin consists of really the definition of the current state of the materials and the equipment and the manufacturing process. Now, this data is accessible to data consumers. Those data consumers can be things like production dashboards, they can be design tools, there's all sorts of different types of consumer, but many of those consumers can actually feed data back to the digital twin. Now, the most common sort of sets of uses of digital twins are, one, visibility into operational status and responding to unexpected events. So that's where the digital twin provides visibility into the current state to a broader audience and across a broader scope than a single operator of a single machine or a single supervisor dealing with one part of a manufacturing process. Instead, people can see the entire value chain end to end and can understand how the decisions that they make locally can impact the entire value chain. And this type of application tends to be strong on visualization, doesn't require a lot of data science, and provides a lot of value to operations. The next thing for digital twins is really the optimization. Now, we've been optimizing stuff down in the control system for my entire career, but by bringing together data from across the manufacturing enterprise, it makes it possible to raise the scope of optimization. So we can go from optimizing one machine or one part of the process to optimizing the entire value chain. And companies are beginning to see, the advent of, integrating across the whole company and reaching into the supply chain, both upstream and downstream, from both a planning and optimization point of view. Things like responding to unanticipated orders, responding to changes in spot price for fungible goods, and so on. And then the sort of most leverage, largest area for significant change is really where you can use the digital twin as a jumping off point for forecasting of what may happen, and also looking at all sorts of alternative cases of, well, what if we increase capacity at this part of the plant by 10%, or what if we bought another 3 machines here, or what if we switched from raw material from supplier A to supplier B. And this is where you can really look at how you can change the way your business operates using factual information from the digital twin. And that's a very powerful area as well. So thank you. I'll hand it back to Alvaro.
Thank you, Dave. So Mohammed, would you like to take this one?
Sorry, I was on mute. Thank you, Alvaro. So, there are many different silos of data that comes in, and what we would suggest is to organize your data in a different fields, and when you run to the predictive analytics and analysis, a lot of these data may not coming from different equipment may not make sense versus one equipment versus other. So you have to go through and clean the data and silo these data accordingly, so that later on you know which data is coming from which silo. So organization of data is very important key thing early in the game. Early in the game, you need to do that, and then if possible, I like crawl, walk, and run. I evangelize to use crawl, that is some modeling before the real data comes in, get some simulated data, and then run some modeling, and that way you can identify the areas where you can increase efficiencies before the real data comes in. Once the real data comes in, and it will improve your modeling and the use case set, and you will be able to increase the efficiency in the manufacturing by days. And if you do go the legacy ways, it might take you weeks, it might take you months, and from all the experience from the local travel knowledge to figure out where is the efficiency. But with the ML and then organizing your data and cleaning your data and all that, you can really go and increase your efficiency. And that's it. That is all about the digital twin is all about increasing the efficiency in the manufacturing plant. So back to you, Alvaro.
I would like
Thank
to.
You. Thank you, Mohammed. And if I may add, I guess the key aspect around the digital twins is that in many I guess mindsets at the moment, The digital twin is related to an overall 3D environment, but back to the point that we were making through the value chain, that basically changes depending on the nature of the stakeholders who are basically utilizing the digital twin and the type of decisions that they need to make as well. Because it's one thing is to present a 3D environment to potentially a person that is working on the technology and innovation space, where an executive may not be looking at a 3D environment, may be looking at more like a dashboard. And if you need to basically drive certain level of insights down to the operator level, then the interaction with that operator may change to a human-machine interface that basically sits into the control system. The key aspect here, as we start basically addressing some of the use cases, is that it's important to take that into consideration, is how people actually take that, that decision making. And you don't have to do everything at once. You can actually thin slide the digital twin component back to the point that Mohammed was making around crawl, walk, and run. You can start with, identifying a particular thin slide use cases. But what is important to address in there is that one of the most fundamental aspects as you start addressing those thin slides is the cataloging of information. That's where you are going to basically drive the relationship between the data, the knowledge, the insights, and even applying, standard and guidelines and best practices that resonates with those particular use cases, and also helps enhance the decision making that the client will have. So that's the key aspect. And then after that, you can decide whether the information will a 3D environment, will be presented to a dashboard, or will be presented down to an HMI. So that basically provides quite a bit of flexibility, and for us, it's about enriching the content and organization of that information as you go along.
Yeah.
So just to summarize as well, 3 areas of impact to unlock industrial intelligence, including digital twins. Number one, there is a need to bring the OT and IT data from various sources together. And what we're finding is the direction is through a data lake. Data from various sources involve real-time streaming, historical and metadata. Data will need to be aggregated, enriched, and organized as data contracts to get ready for various advanced analytics applications. Number two, data science is applied to generate insights and recommendations to various stakeholders, from a specialized, analysis such as fluid analysis to better calculations of the equipment, health indexes, or risk scenario analysis to plan your maintenance. And that basically brings number three is a risk-based asset performance management approach, where we offer a package solution with strategy libraries that offers domain knowledge and content to guide our data science models. As your digital twin strategy evolves, more sensors and data can be added. Many of these sensors will become smarter, sending data directly to the cloud and offer as a service to you as clients. The ability to consume this data will make the data science models and insights more robust, enhancing further the scalability and making more cost-effective your digital twin strategy. So let's look at 3 examples where we are helping our customer re-architect their approach. So number one is from a major energy company. It has a very integrated oil and gas and as well manufacturing shop, including renewable power. They are looking to commoditize time series data across the enterprise to reuse that information, so to drive innovation across the board, and that includes standardizing patterns towards the use of enhancing their current operational applications, machine learning, and reporting development. So we are taking time series information from all of their enterprise historians across multiple business units, including the asset hierarchies that they incorporate in that, and then they are certainly adding additional sensor technologies to those equipments, bring it down into a central repository into the data lake, where we provide that information to build their digital twins strategy, including analytics and reporting and organization. And through that process, what we are aiming, or the client is aiming, is to optimize their fleet for optimization and fleet benchmarking, and as well to streaming the costs and applications of source sensor technologies, and then driving failure prediction and root cause analysis across the organization. The second example that we have is more from an automotive manufacturing shop. In this particular case, the client is looking to to manage the volumes of information, to convert it into insights and alerts that can help guide their supporting team towards improving the tuning of the equipment as the car go through the line. There are certain quality factors that get checked through that process, and what we are aiming to identify through this process is helping identify the deviations, the larger deviations, so they can optimize as well their team and optimize their chief across the board. So through that process, we are not only helping enhance the downtime and visibility of the asset, but we're also, through the use of advanced analytics, reducing the number of alerts that they typically get to drive further focus towards the enhancing and calibrations that they need to have for quality component. And at the same time, obviously impacting any quality issues just before they finalize the making of that car. So that's the second example. And the third example that we have is more from Davey. Dave, would you like to take this on?
Yeah, sure. This is a really fun one because we happen to do the complete scope, soup to nuts. So not that Uptake generally does IoT hardware, but we actually did end up designing, specifying, and installing the IoT hardware for this particular client. So this was really neat because this was a company that understood what business outcomes they wanted to achieve, but didn't understand how to do it technically. So Daisy is a textile manufacturer based in Canada. They actually weave the cloth here. They make fire retardant reflective strips. And what they did was they have a large number of pieces of equipment, but they are not what you would think of as highly automated, highly monitored. So they couldn't actually tell when equipment went down, how long it had been down for. They could just tell that it had failed when an operator walked by and saw the red light on the top saying that it had shut down. So for them, they wanted to understand how often things broke, what reasons they broke for, how long equipment was down for, so that they could then move on a journey towards more, not only more effective operations, but understand their equipment utilization and which equipment worked better for different products. So what we did was we helped them actually instrument and automate data collection from their equipment, brought that data into Azure, and built a downtime tracking application very quickly and inexpensively for them that allows them to see in real time when one of their pieces of equipment shuts down and the reason reported by the IoT edge device for the downtime. That when the equipment goes down, it sends out an immediate alert that is received by the operator and the supervisor, so the operator can go to the machine and restart it. And in some cases, what they're getting for simple shutdowns, they're getting downtimes that used to be 20 minutes or so are reduced to like a minute. So first of all, there's just a first level improvement in production. But it's the knock-on effects that are really, really interesting because now they know when their equipment goes down, why it goes down. They also understand which machines are more reliable than others. They have much better visibility into their actual manufacturing capability. And it's allowed them to go from a make-to-stock system where they have to make material based upon projected sales to a make-to-order system where they take orders and make the stock for that specific order. Now, for those of you not in the manufacturing world, that might not seem like a big thing, but in the manufacturing world, make to stock involves all sorts of issues around finished goods inventory and working capital tied up in product that you're making based on a statistical projection, whereas make to order, while more difficult to achieve, is much better from a cash flow point of view. So they've been able to shift from make to stock to make to order. They've been able to avoid capital purchases because they now understand their capability of their equipment. They've been able to reduce their labor costs because they know what their equipment can produce, and so they don't have to staff 2 shifts all the time, and so on. So the business impacts of this digital twin are really being very effectively leveraged by this company to sort of understand what they can do with it. Anyway, thank you very much, Alvaro.
Yeah, thank you, Dave. So yeah, that resumes, I guess, our conversation. So back to you, Liana.
Wonderful. Thank you so much for the great discussion today. Greatly appreciated. If you haven't already registered for the Industrial Trio series, I strongly encourage you to. There's 6 different industries, 3 different briefings, and only 20 minutes each. The manufacturing one for asset performance monitoring and management is coming up on November the 4th. So coming up in the next couple weeks. In September, we did the data lake. That was our first briefing. And so that's OT-enabled data lake and liberating your data and bringing everything into Azure and how to do it. And these are 100% educational case studies, not sales pitches, and really focused on real life activities of what people have been doing. And October, November, we're focusing on asset performance management. And like I'd mentioned, November 4th will be the next one for manufacturing. And then over November and December, we'll be focusing on AI-driven data science and, you know, that competitive advantage with industrial intelligence. So please join us if you can. I'm going to hop over now to the chat to see if there's any questions. And if you haven't already asked any questions, please feel free to post them in the chat. There's a quick question. Are you saying that you're offering a system to create different digital twins on assets depending on the person that needs access to the data? And also, the deployment of those digital twins, can it occur in a phased approach?
Absolutely. So this is the point of that lenses slide, is that any given large organization is going to have different communities of consumer for operating data. There are going to be people who are interested in the process. There's going to be people who are interested in the equipment. There's going to be people who are interested in inventory and so on. And if you try to build a single digital twin for the entire enterprise, you're going to end up spending too much time in analysis paralysis. Instead, what you need to do is build digital twins to solve specific problems. To get back to that first definition that Alvaro talked about, how a digital twin is, you know, based on delivering for outcomes. And then what you need to do is recognize that any model of a system, it by definition leaves out some details on purpose, because you're the only way to completely replicate the system is to completely replicate the system, which takes a long time. So instead, what you need to do is recognize that these models will have to be extended over time as you find more opportunities for, you know, adding more equipment, like at Daisy, where they're going from 23 pieces of 23 looms to 40 looms, or different types of equipment where they go from the looms into the finishers and the dryers and the winders and so on. So you have to start trying to solve a specific business problem and then extend them in, you know, as the business opportunities present themselves, as your ability to take advantage of the data extends. So yes, thank you. Great question.
Yeah, if I can add to that, Liana and Dave. So one of the key aspects that as well people need to also consider is that technology is also keep emerging and changing over time. But one of the key fundamental aspects that will remain and stay is how you actually relate the information, how you catalog your data. Who will have known that, you know, in this time we will have, you know, augmented reality type of environments that you can, you know, embed yourself into it. Who knows that in the future, rather than being an augmented reality, it will be more a voice command component. And what is going to be very important as we start basically the technology start evolving is how you actually manage that level of correlation between information and relationship components. So that's one of the key fundamental aspects if you think around the digital twin component as you start basically driving that thin slide approach is how do you abstract the digital twin concept, and that's the important aspects around cataloging your data.
And the other, Alvaro, if I may add on the phased approach is absolutely, I think we stressed earlier on the crawl, walk, run methodology, and then you sort of based on user groups or the consumers of data, you kind of evolve and build on it, you know, all the use cases as well as the data that is needed. Catalog is absolutely important. Data cleansing is another piece of it. And absolutely, all that makes a lot of sense in this approach.
Wonderful. We have another question. Can you please talk more about the analytics in each of your use cases? How exactly did you help generate those benefits through data analytics?
Okay, so I can take the one for the automotive in general. So the automotive is more around the number of incidents that you will happen through the process. So keep in mind, manufacturing facility for automotive will have multiple cars being made in the shop. There are multiple jigs, which are areas within the facility where you start assembling components to basically build up that car. And then through that process, you start doing multiple check-ins around the deviations aspects. So the sooner that you can find those deviations, or the earlier that you can find those deviations, the better, because at the end of the day, the number of potential cars that you manufacture will have less claims, less impact in terms of your sell process, right? So that's basically what we're doing for this particular client is helping analyze all of the information that they are extracting from all these gig systems and as well perceptron systems that basically checks all these quality factors and be able to provide in a simple manner to the process optimization team what deviations will take priority, and keep in mind some of those decisions that they will have to make is whether they will stop the line or they will do the activity for tuning and calibrating these jigs through the lunch break or things like that. So all we are doing is basically helping them identify the quality as early as possible to minimize the potential impacts of out of spec cars that gets at the end of the line, and at the same time we're helping them optimize their resources and the crew to drive priorities in terms of the activities that they need to carry on for the day.
Alvaro, I'd like to add. Go ahead, Dr. Shu. You first, please.
Well, I was going to speak to the Davy example, but feel free to put in a comment, and then I'll talk about Davy.
You first. Go ahead with your example, then I'd like to add to what Alvaro mentioned.
So if we talk about Davy, so there were two significant pieces of analytics. One is honest to goodness edge analytics, and the issue there was the IoT device had to do a certain amount of relatively simple but critical analytics to determine the cause of the equipment shutdown. There was, we would think of this in the sort of big computer world as a form of signal processing. It had to do with how we were collecting the data and the fact that the raw input signals were not very reliable. So we had to do some reasonably sophisticated logic out at the edge to turn raw voltages, to be perfectly honest, into a definitive statement that a piece of equipment had shut down for a particular reason. So that's one place where we did the analytics. The other place where we did the analytics was really on the statistics around shutdowns by length, by cause, by type of product, by machine identifier, and so on. And that's that type of operational business intelligence analysis is easily done in tools like Microsoft Power BI once you have high quality input data. So if you have got highly reliable data from your input source, then there's all sorts of self-serve analysis that you can do to look at, which, in their particular case, which looms could be trusted to run overnight on which products without an operator standing there. Which looms were better at making particular cloth than others. What effect did environmental impacts like room temperature and humidity have on different SKUs, and so on, right? So there's a bit of honest to goodness hardcore signal processing done at the edge, and there was a lot of self-serve operational BI done on the data after it had come to the cloud.
There are multiple aspects, as Dave and Alvaro mentioned, right? In this data analytics, of course, capturing all the events, what events are the most critical, what alerts are most critical, and then you kind of build that on based on each of the either user group or industry verticals and use cases you have, right? And that's how you actually integrate more analytics and also grouping of that data, of course, cleansed data, and then reporting on some of the key important KPIs that you already have predetermined, just whether it's operational insights, real time, near real time, and then the analytic based on the history of the data. But definitely, it's a build process that kind of evolves as Dr. Shook and Alvaro mentioned. Yeah, thank you.
Wonderful. Well, thank you everybody for the great discussion today. Greatly appreciated. We've gone through all the questions in the chat. So thank you for your time and have a wonderful day, everybody.